This video is trying to just help you think through and understand question 3 from the topic 14 homework. Okay, so in this question we have got a maths problem. So let's have a look at how I would attack this question. The thermal energy needed to change state of a substance from solid to liquid means that this thing is melting. That's immediately making my mind go, oh, I know which equation I'm going to be using, but no spoiler there, I think. Calculate the thermal energy that's needed to change state. So the thermal energy is what I am trying to work out, and when I look down here I can see that they want that in the standard unit of joules. I'm looking to change the state of a mass of 3.5 kilograms. So that in the question is in standard units, which is great. Makes it nice and easy for me. The substance has a specific latent heat. Specific latent heat of a value in standard units again. Perfect. So they're giving us the clue that we need to use an equation from the formula sheet, and the equation that we would need to choose would be that the energy needed to change state is the mass, which in this case is 3.5, times by the specific latent heat, which in this case we know as well, all in our standard units. So the energy that we are trying to calculate can now be, with the aid of a calculator, calculated to be here. And we could choose to neaten that up. That would be 1.18 times 10 to the 10 to the 6 joules, which gives a nice polished answer at the end. Explaining a reason why the change of state from solid to liquid, melting, is described as a physical change. Well, if we're going from solid to liquid and we melt, there is no chemical change. We could easily pop that liquid into a freezer, cool it back down, and we could freeze it back into a solid. So this is a physical change because it isn't a chemical change, it's reversible. We can get back what we've started with. So there is no chemical change because you could freeze it back into a solid. It is reversible, would be my final answer. The first thing that jumps out at me is there is a table. When there is a table in a question, you're going to have to refer to it. So I'm bearing that in mind before I even read what the question is. So looking at the question, it's reminding us about solids, liquids and gases in terms of particles, and it's all about the density of these substances that are all at the same room temperature. So that means at room temperature, water is going to be a liquid, lead is going to be a solid, and air is going to be a gas. The table's comparing the densities, so we've got a high density for lead. That's because the solid has got those particles packed in very neat rows, just vibrating, closely packed in. And then we've got the liquid water, and that is our medium density, where our particles are still close together, but they are moving past one another a little, more kinetic energy stored. And then in air, our gas, that's our low density, and that's because the particles in the gas are far apart, very small intermolecular forces. They're zooming about in all directions, huge kinetic energy store in comparison with the other two, but not very many particles in the same amount of space. Density, all to do with, remember, density, the mass per unit volume. How much matter have you got packed in? How many particles have you got packed in to a certain amount of space? So the question is actually asking me to use the kinetic theory to explain in terms of particles. So that's this bit that we've just revised, the difference in the densities between just the lead and the air, so we can actually ignore the water at this stage. Okay, so the lead that would have sunk in the water because its density is greater, and the air that would float above the water because its density is less, we can actually ignore the water completely. In this answer, I would be focusing on the fact, straight away using the table, the density of lead is greater than the density of air, because the lead is a solid at room temperature, and its particles will be closely packed in neat rows. Because density is the mass per unit volume, the lead has more particles packed into the same volume at the same temperature compared to air. That would be my final answer. It's application question. This time it looks like we're going to have to recall an equation because we're being asked to calculate the density of the steel. So I'm going to need to recall my density equation. There you go. I'm already there with 1 mark. Density is mass divided by volume. So let's have a look at what information they've given me in the question. One of the steel nails shown in figure 8 has got a mass, that's my M, of 2.7 grams. Now I'm going to peek down here because I did notice there's only 2 marks for this question. And when I peek down here I can see the final answer is to be given in grams per centimetre cubed. So I don't need to convert units to standard units of kilograms here. And with the volume I can leave it in centimetres cubed. So the volume is the other thing I've been given here, and that's 0.31. So if we decide which equation we're going to use, done that. Density is the mass, which is 2.7 in this situation, divided by the volume, which is 0.31. And on my calculator, I then calculate the answer to be, and that would be in grams per centimetre cubed, which is what I need the final answer in. My final answer. Reach the last part of question 3, and we're going to finish with part D. We're being asked to describe how the movement of the particles, there we go, in a substance changes as the substance is cooled down, so energy is removed, towards a very specific number here, minus 273 degrees Celsius. So we're removing the kinetic energy store of the particles. We're giving the particles less and less kinetic energy. Therefore, we are reaching a point at which the particles will have no kinetic energy store at all. Minus 273 degrees is absolute zero. 0 Kelvin. So that's what this question is really testing. Do you understand what happens to the movement of particles at absolute zero? So my answer would be, as a substance is cooled, the particle speed will decrease until at minus 273 degrees Celsius, or absolute zero, they are not moving at all. They are stationary at 0 meters per second, because absolute zero is where particles will not have a kinetic energy store. My final answer.